do not see there at the present time, as existed during the Maunder minimum when there was hardly any sunspot activity and lots of cosmic rays getting in, forming lots of clouds. And it's interesting, if you look at practically any painting that's taken from that, or that was done during that interval, they always tend to have this sort of a hazy, cloudy sort of look to them, which reflects the sort of enhanced clouds conditions that existed, which resulted in the overall cooler type conditions. Now, the final thing that I'll talk about right here is we looked at a little ice age record actually from our core records up at Belize Inlet. So I'm not going to bore you. There's a way that we can look at the distribution of fossils in particular samples that live at the present time. So you go all different conditions, low oxygen, high oxygen, warm, cool, or whatever, and then we can correlate them to tell us about what the conditions are that exist at that present time. So this is a diagram which shows this. Here's the more interesting bit right here, is that we can actually then look at these different species that live around here, and you can see that in a very short freeze core that we took from Belize Inlet, that there was a radical change in this place. So there was some of these species were very abundant deeper in the core, then we changed to a totally different set. And using this thing called the transfer function, we can ascribe oxygen values and temperatures to these distribution of these fossils. And what we saw, the interesting thing is that at a point right here, and I think I'll move to another slide to show that, is that here is the transfer function. This is dated from about 1000 AD up to the present time in here. Up until about 1500 AD, oxygen levels in Belize Inlet were very low. Then almost instantly, they moved up to much, much higher levels. The same thing with temperature. Temperature was higher, then almost instantly around 1500, we moved to a lower temperature, which stayed all through the 1800s until the latter part of the 1800s when it gradually, the temperature started to drop off and oxygen started to drop off as well, which matches up beautifully with the Little Ice Age. So I think what we're seeing here is another one of these Gleisberg cycle shifts that we're looking at. And here's just a little model to show how this happened, is that Belize Inlet, during the time when oxygen levels were low, basically it rained a lot in this area. So enhanced rainfall, which resulted in a very thick wedge of fresh water going across that very narrow little Natwako Rapids out here. Water couldn't get in from the open ocean at all. And it resulted in this water in here becoming very stagnant. Then, as we moved on later, Belize Inlet, as we moved, the North Pacific High began to dominate in that area. It resulted in lower salinity water leaving, but it's a thinner wedge, and some water could actually get in, and oxygen levels start to go up again. And so it can happen very, very quickly. It doesn't take much. If you add a lot of water into this very narrow little inlet up there, it can result in a serious restriction of the amount of exchange going on and almost instantaneous development of anoxia. So this is our Little Ice Age record that we see in this region as well, which is controlled by, again, these movements in the North Pacific High and Aleutian Low. It's not upwelling. We're looking at changes in actual rainfall at this stage. So finally then, the conclusion that we've drawn from this research, carried out over several years here, that basically we see very conclusive, I'd think, evidence of natural cyclic phenomena, which we think is driven by these celestial variation, which has an impact of the solar forcing basically being modulated by cosmic ray flux, which seems to be a prime driver of not only climate in the Northeast Pacific, but also has a profound influence upon biological processes as well. And that is it.